Hello, my dear students. Welcome to the class of 12th English Medium. The subject is Statistics, Part 1, Chapter 1, Index Numbers, brought to you by Vitan Sir. In this chapter, previously I solved section C. You can find that video at the top right corner of your screen. Now I am going to start with the section D of this chapter. That means the questions with 3 marks weightage. Now you must remember that this chapter belongs to the weightage of MCQ 1 mark questions, 2 mark questions, 3 mark questions and 5 mark questions. The section E given in this chapter is only for the practice. The questions from that sections are not asked in the board exams because this chapter does not have any questions belonging to the 4 marks category. So the solution for section D is in this tutorial, and next time I will be solving section F directly for the 5 marks. I will not be solving section E. Okay, let's start. As usually, I'm not going to solve the theoretical portion. You can find the answers to theories in my previous tutorials, from tutorial number 1 to 8 or 1 to 9 or something. You will find all the theoretical answers in them. Here I am only solving the sums. So the first sum in this section is question number 7. The prices of 3 items among 5 items increased by 50, 90 and 110%, and prices of 2 items decreased by 5 and 2% in the current year 2015 compared to the base year 2014. If the ratio of the importance of these 5 items is 5, 4, 3 to 1, find the index number of fuel prices for the year 2015. Now dear students, as it is given increased by, so we will add 100 in all these percentages, and decreased by, so from 100 we will deduct these both percentages to get index number directly. The importance are given in the ratio format, so that's weight. Naturally we have the index number, we have the weight, so we will use the weighted average index number method for calculating this sum. Items I will just assume are A, B, C, D, E because 5 items are there. Now the first item is increased by 50%, so 100 plus 50 will make the index number here 150. Next is 90, so 90 plus 100 will make 190. Then 110 will make 110 plus 100 210. Similarly, 2 items have decreased by 5 and 2%. So 100 minus 5 is 95 and 100 minus 2 is 98. So my dear students, these are the index number for the given question. The weight, that is the importance, is given through ratios. So just write down the ratio as it is given: 5, 4, 3, 2, 1. The next step is multiplying index number with the weight. So IW, index number is 150, weight is 5, so 155 is 750, 194 is 760, 210 3s are 630, 95 2s are 190, and 98 1s are 98. So we get the weights, we get the IW, make a total. So 15 is the total of weight, and 242 8 is the total of IW. Next we have to give the tidal fuel price index number. The formula is IW upon W. Just write the values 2428 upon 15 and you get the index number, that is 161.87. Just write a statement that there is a rise of 61.87% in the current year compared to the base year. If you want, you can add the statement there is a rise of 61.87% in the fuel prices in the current year 2015 compared to the base year 2014. You can add these words in the statement. It will improve your answer. But basically this is the method which you need to follow for this kind of questions. Increase means plus 100, decrease means subtract from 100. Moving on. Question number 8. Find the FPI from the following data about average annual income of workers in a company from the 2008 to 2014. Take 2008 as base year. this is the data. You have the year 2008, 9, 10, 11, 12, 13, 14. You have the average income in 10,000 rupees. That is 36,000, 3,60,000 rupees, 4 lakh rupees, 4 lakh 80,000. In short, 36, 40, 48, 52, 60, 80 and 95. These are the values. You need to calculate the fixed base index. That means the first value, because it's the base year, because 2008 is the base year index number is always 100. So for 2008 the index number will be 100. Now we are taking a fixed base index number, so the current year 2009 and the base year 2008, that is 40 divided by 36 into 100, and your answer will be 111.11. Similarly for 2010, 48 divided by 36 into 100, 133.33. That means that each time the base year 2008, the value 36 will be constant and the current year value will keep on changing. This is the basic index number, P1 upon Q0, P1 upon P0 into 100. Here the P1 will keep on changing and P0 will be constant, 36. So for 2011, 52 divided by 36 into 100 is 144.44. For 2012, 60 divided by 36 is 166.67. Similarly for 2013, 80 divided by 36 is 222.22. And for 2014, 95 divided by 36 is 263.89. So this is your fixed base index for the given year. It is a very simple sum, very simple question, nothing hi-fi here. Okay. Question number 9, the index numbers. You don't need to write any statement for this kind of sums, just show the calculation as I have shown here. The index numbers of average closing prices of shares of different company in different months with the base January 2014 are as follows. Find the chain base index number. Index numbers are already there. You have the months January, February, March, April, May, June, and you have the fixed base index number for these given values. The base year is January 2014. The base month is January. We have to calculate the chain base index numbers. Now for that you need to remember the formula for converting a fixed base index number into a chain base index number, and if you have forgotten, just check out the tutorial at here, around here, where you will see how to convert a fixed base index number into a chain base index number and how to convert a chain base index number into a fixed base index number. So at that point you will get your tutorial. So how to calculate a chain base index number? Fixed base index number of the current year divided by fixed base index number of the previous year multiplied by 100. But for the first year, just copy whatever fixed base index number is here, because the base is given. When the base is given, just copy the first fixed base index number as the first chain base index number. Next, current fixed base index number divided by previous fixed base index number into 100. So 104 upon 100 into 100 is 104. 105 divided by 104 into 100, so that is 100.96. Then 108 divided by 105 into 100. Okay, current divided by previous into 100, it is 102.86. 109 divided by 108 upon 100 into 100, 100.93. And 127 upon 109 into 100 is 116.51. So my dear students, this is how you convert a fixed base index number into a chain base index number. And as you know, just refer that previous tutorial in case you have forgotten how to do that. Next is question number 10. Find the fixed base index number from the chain base index number given below. So it's simple. You have to calculate fixed base index number from the chain base index number. The years are 11, 12, 13, 14. The index numbers are 120, 90, 140 and 125. And the fixed base index number is what you are supposed to calculate. Now in this question, we have to use the chain base index number to find the fixed base index number. So just copy the first chain base index number here as the first fixed base index number. The next formula you can find in the same tutorial which I just told you now, where the current CBI is multiplied by previous FBI. These cross values are there. The current CBI is multiplied with previous FBI and divided by 100. So 90 into 120 upon 100 is 108. Similarly, the current CBI is multiplied with the previous FBI or preceding FBI, we can say 140 into 108 upon 100 is 151.2. 125 is multiplied by 151.2 divided by 100 and you get 189 exit. So this is how you calculate a fixed base index number from the given chain base index numbers. Question number 11 is find the chain base index from the following data about prices of an item. Now this is a simple question. You just have the years, you have the prices, and you are supposed to calculate chain base index number. How to calculate a chain base index number? Simple. The first value is taken as 100, and for the next values take the current year, divide with the preceding year, immediate preceding year. So if I am taking 2010 45, I will be dividing it with 2009 40. So 45 upon 40 into 100, 112.5. Now if I am taking 2011 48, so I will divide it with 2010 45. So 48 upon 45 into 100, that is 106.67. Then if I am taking 2012, I will divide it with 2011, so 55 divided by 48 into 100, 114.58. Then 60 divided by 55 into 100, 109.09, and the 70 divided by 60 into 100 is 116.67. So this is how you simply calculate a chain base index number from the given simple data. Okay, so we have calculated simple fixed base and chain base index number, and we have also calculated conversion of fixed base to chain base and chain base to fixed base. We have to find the cost of living index number from the given information of the month of April 2015 regarding group index numbers in weights of items of living of industrial workers. Okay, so we have various groups of items which is used for calculating the living cost of industrial workers for the month of April 2015. This is the data. We have the groups A, B, C, D, E, F. The index numbers for each group are already available. The weights for each group are also available. We have to find the multiplication of index number with the weight, that is IW, and then calculate the weighted average index number or cost of living index number using family budget method naturally. So just multiply 247 with 44, you get 10,868. 167 multiplied by 20 is 3340. 259 into 16 is 4144. 196 into 6 is 1176. 212 into 10 is 2120. 253 into 4 is 1012. Make a total of the weight here, which is naturally 100, and make a total of the IW here, which is 22,660. So cost of living index number is summation IW upon summation W, weighted index number method, and 2260 divided by 100 is 226.60. So just write a statement. There is a rise of 126.60% in the current year compared to the base year, or we can say that there is a rise of 126.60% in the cost of living of the industrial workers for the month of April. You can write either of these two statements, whichever you want, it's okay. The 13th number question, if summation P1 Q0 is to summation P0 Q0 is 5:3, and summation P1 Q1 is to summation P0 Q1 is 3:2, find last PO, Paasche and Fisher's index number. Now you might be wondering that how to solve these things, but we know one thing, that is to can be written as divide by. So if I am calculating last PO's index number, first I must write down its formula, that is summation P1 Q0 upon summation P0 Q0 into 100. Now if you look at this value and if you look at this value, you will see that okay, they are similar. So if I am writing this is to value in the divide value, then naturally 5:3 will also become 5 upon 3 into 100, and you get the answer 166.67. It's pretty simple. It may look complicated, but it is very easy. Similarly, if I am calculating Pasche's index number, and if I write the formula for that, you can see that this P1 Q1 and P0 Q1 are quite similar to these values, and that means I can use this 3:2 for calculating Paasche. So 3 upon 2 into 100 is simply 150. And Fisher's index number is very easy because it uses the last pair and Pasche's index numbers geometric mean. So IL into IP whole root, that is 166.67 into 150 whole root. Just multiply these values and whatever is the answer, root it, you get 158.12. So this is the last pair, Paasche and Fisher's index number for the given question. last sum of this section. If the ratio of last year and past year's index number is 4:5 and Fisher's index number is 150, find past year's index number. Now we know that last year and past year's index number has the ratio 4:5. Ratios can be written as the divisional values. So IL upon IP is 4 upon 5. I will just take this IP and put it here. So it is 4 IP upon 5. I will keep it as it is. I have got the value for IL, that is 4 IP upon 5. I will use it in my Fisher's index number formula, that is IF is equal to IL into IP whole root. Whenever we are calculating last year past year Fisher's index number, we have to use this formula. Usually always have to use this formula because it shows the relationship between Fisher, last year and past year. Sometimes the question is asked, what is the mathematical relationship between last year past year and Fisher's index number? You can show this. Put the values whichever we have. Now IF is 150 and IL is 4 IP upon 5. Okay, so I'm just replacing IL with this value, that is 4 IP upon 5, and IP is as it is. Now whenever I want to remove this square root, I need to square the opposing value. So I will just square this and I will multiply this IP with this. So 4 upon 5 into IP square. Now 150 square is 22,500, and next I am going to change the side of this 4 upon 5, so it becomes 5 upon 4. 22,500 into 5 upon 4, and the answer for that is 28,125. This is square, so if I want to remove the square, I need to make a root of this. So root of 28,125 is 167.71. So the past year's index number for this sum is 167.71. Thank you very much, students, for watching this section D solution by Vitan sir. Next time I will be solving section F. Thank you very much for watching. Let me know if you have any doubts about this, and wait for my next tutorial. See you soon. Welcome students to Vitan sir's Unacant Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you, and I will see you in the next video.